All right, let's weld.
Before we get into the fillet welds, we need to talk about one main shortcoming of short circuit MIG welding, and that is it just doesn't penetrate through hot rolled mill scale as well as some other processes. I'm going to make a T-joint weld using really low settings and doing some things wrong just to illustrate a point. I'm going to use a really long stick out like I shouldn't do, and I'm going to keep the arc not on the leading edge of the puddle but riding back on the middle of the puddle and just letting the puddle flow ahead. You shouldn't do that with short circuit MIG welding. You want to keep that arc on the leading edge of the puddle, especially on hot rolled mill scale, because you just don't have that arc chewing through that mill scale like you need it. Let's do a little quick brake test on this. We'll put a forward wrench on here. Minimal effort. It just snaps. Hardly, I could have done it with one hand easily. It just didn't bite through the mill scale. Now I welded this at really low settings, but just to illustrate the point that if you're not careful with short circuit MIG and welding over hot rolled mill scale, you got problems. It didn't even penetrate into the root. It just laid up against there. And straight line, you don't want to see a straight line on a fillet weld brake test. This grinding wheel is designed for hot rolled mill scale, and so what I'm going to do is I'm going to remove the mill scale and we'll leave my machine settings the same. I'm going to use a short stick out with a much better technique, but the machine settings are going to be identical. So the main difference is I just removed all the mill scale down to clean bright metal. I'm going to use a technique that keeps that arc up in the front of the puddle. I'm still going to use a slight pushing angle a little bit, but a much shorter stick out. It still doesn't look nearly hot enough, but the fact that there's no barrier, there's no mill scale to prevent it from penetrating, should make a lot of difference when we go to break this one. That's probably a little bit smaller or shorter weld than we had the first time around, but let's just see what it does. Now I'm about 200 pounds here. My feet were coming up off the floor. I could barely make it give, but putting a cheater bar on there, was able to snap it with quite a bit of effort. And again, it's the same exact settings. And that time, the difference is it actually bit into that bare, clean metal. Just goes to show you what difference cleaning metal can make. All right, let's get into some fillet welds. We're going to start off with some thin stuff. 063 wall square tubing. First up with just this little 2F fillet weld here. We're going to stick to 2F and 1F in this video. The settings I used are a little bit hotter than what the machine recommended. But for a flat or horizontal fillet weld, you can get away with a wide range of settings. And what am I doing here? This is called rolling the cylinder. This is an old-timer trick. This is a cylinder of C25 gas. When a cylinder has been sitting a long time, all I know is it welds funny. You can argue all day long that gases can't separate except under sub-zero temperatures or something like that, but if you've ever welded with a cylinder that's been sitting there forever and then you do this, you notice it just welds better. Again, I'm using a hotter setting than what's recommended for a 16 gauge, and this is with 025 wire. Alright, let's get started here. I'm going to take a few dry runs as always, just to kind of get used to what I'm going to do, make sure nothing's going to hang me up, make sure I'm comfortable, and here we go. I have a couple of different 200 amp MIG machines. One of them is a Hobart and it's a transformer style. This is a Lincoln and it's an inverter style, and I really like the way both of them run with 025 wire. Super smooth arc, especially on something like pretty thin like this, or up to about 1/8 or 3/16 of an inch works pretty good too. Okay, let's step up now to 11 gauge, roughly 1/8 of an inch thick, using 030 wire. And I'm going to start off with a little bit of a push angle, using just a little bit of gun manipulation. This is kind of like, I don't know, I'm just in the habit of doing this, especially on when I'm using the 030 wire and short circuit MIG. I'm just in the habit of doing a little bit of oscillation like this, a little series of loops. And I may have to get out of that habit, to be honest with you, but old habits are kind of hard to break. There's always lots of discussion on pushing versus pulling, and I think that really comes from because there are so many different modes of transfer. You know, there's spray transfer, short circuit transfer, etc. With short circuit transfer, I prefer to pull, but I push also. Just depends on the situation. I've done these kind of tests before. I generally get a little bit better penetration pulling, a little less spatter pulling, but not much difference. Not like night and day. There are subtle differences in the bead profile and penetration. But we're going to test it and show what each one does. All right, that's a series of sort of like U's or cursive E's, and which one you use will determine how much buildup you have in your weld, and it also affects your travel speed. Like if I'm looping back into the weld like this, that's going to build up a little bit more, and that's going to slow down travel speed. Whereas if I don't loop back into the weld at all, I just keep moving forward, that speeds up travel speed and usually, spreads the ripples out and doesn't build up as much. So now it's time to cut all these, kind of see where I'm at. Some subtle differences, but definitely not like night and day. So now let's go up to 3/16 of an inch, and that'll be with 0.35 diameter wire. And this will be in the horizontal or 2F position. Hardly any difference than 1F and 2F, but this is the technique, pausing a little bit at the top to kind of fill in and avoid undercut. Notice the pause at the top, just briefly. I've got the machine set a good bit lower than machine recommended settings. That is trying to just achieve a certain MIG-like TIG look. And it slows the progression down a good deal. I'm going to use that same piece and just weld the back side of it, so it's kind of like an inside corner, but it's a fillet weld, just like a T-joint. And I'm going to use much hotter settings. These are closer to what the machine or miller recommends for a fillet weld of this thickness. And you can see the speed is much faster. I'm trying to kind of stay up in the front of the puddle. I'm trying to move on so that I don't crown up too much. And I am using a slight pull angle right here. I'm trying to keep my stick out distance pretty short. And for short circuit MIG, that's about a ½ inch, and the only way you can do that is to make sure your contact tip is not recessed way back up in the nozzle. It should be around flush. I like mine even sticking out just a little bit. But I like to test welds. This one's welded outside corner joint as well as an inside fillet. So I like to cut it, polish it, and etch it. The solution I use here is a blend of different acid that's designed to remove heat tint off stainless. And that reveals some pretty decent penetration. All right, let's take a look at a slightly different technique now. We're on a 1/4 inch, but I'm going to use a slightly different technique that still keeps that arc in the front of the puddle and keeps it down into the root of the joint on that forward movement. It's just a series of V's, sideways V's sort of. And while this is not necessarily the best way to make a pretty weld, it is a really good technique that keeps the arc in the front of the puddle and kind of ensures penetration as long as you got the metal clean and as long as you have the stick out short and you stay up in the front of that puddle. Keep that arc in the leading edge of the puddle. Up next, we're going to do a 1/4 inch thick outside corner joint, and it'll be done in the flat position. I use the settings that were recommended for 3/16 of an inch because an outside corner joint doesn't quite take as much heat as a regular fillet weld on a T-joint. So this is recommended settings for 3/16, but I'm welding 1/4 inch, and as you can see, it's plenty hot enough. But even so, you still need to make the effort to keep that arc up in the front or leading edge of the puddle. You need to keep your stick out short, limit your gun angle, and things should go okay, providing you're welding on pretty clean material. Now, I'm watching this. Seems good and hot. I'm keeping that arc up in the front. It seems like it's hitting the root, but wouldn't it be nice to be sure? So that's why we test things. A good test is worth 1,000 opinions. Now, a fresh saw cut surface is not really smooth enough to get a really good etch on. You can tell some information from it. So I polished this down using a Scotch-Brite pad and then put the etch on it, and it really reveals what's space metal and what's weld nugget. For an outside corner joint, it kind of got in there. If you wanted full penetration, you'd have to gap it a little bit.